Hello and welcome. In this video, we're going to talk about proofs involving transversals. Our goal is that given an angle pair relationship, we can prove and identify lines cut by transversals are parallel. So let's go ahead and jump in. So in our last video, we really focused on if two parallel lines are cut by a transversal, what kind of angle relationships exist. And we knew that if two lines were parallel and they were cut by a transversal, that our corresponding angles were equal, that our alternate interior angles were equal or congruent, that our alternate exterior angles were congruent, and that our same side or consecutive interior angles were supplementary. In this lesson, we're going to reverse that. So last lesson was all about if we know the lines are parallel, then we know these things about relationships between the angles. Now we're going to say if we know that these two angles are congruent, or these two angles are congruent, or these two angles are congruent, or these two are supplementary, if we know the angle relationship, then we can conclude that the lines are parallel. So let's look through and highlight and mark up each of these theorems. So if two lines are cut by a transversal and the corresponding angles are congruent, then this is what's going to be the same each time. Then the lines are parallel. That is the corresponding angles converse. So what we did was we switched the if and then, just like when we learned about what a converse is. If we know that the corresponding angles are congruent, then we can conclude that the lines are parallel. Similarly, if we know that the alternate interior angles are congruent, in this case 4 and 5, then the lines must be parallel. That's the alternate interior angles converse. Then the lines are parallel. So again, we're starting with now, if these angles behave in the way that we know they would if the lines are parallel, then we can conclude that the lines are parallel. So alternate exterior angles converse says if the lines are cut by a transversal in such a way that the exterior angles, the alternate exterior angles are congruent, then the lines are parallel. And lastly, if consecutive interior angles are cut by a transversal in such a way that they are supplementary, so angle 3, the measure of angle 3 and the measure of angle 5 is 180, then the lines are parallel. So again, we're really just saying if these angle relationships exist in the way that we want them to, then we know that the original lines are parallel. We're going to get one more theorem, and then we're going to start using these theorems in practice and in proof. The last theorem that we're going to get in this lesson is the transitive property of parallel lines, which just says if two lines are parallel to the same line, then they are parallel to each other. If two lines have the same slope as a third line, then they have the same slope as each other. That is the transitive property of parallel lines. Now that we have looked at our theorems, let's look at applying these theorems with some examples. Okay, these problems are going to look really similar to how problems looked in the last section, except now it's going to say find the value of x. Instead of saying given that the lines are parallel, we're looking for the value that makes it parallel. So if these two angles, what kind of angles are these? These are corresponding angles. Just want to make sure we're practicing that vocabulary. If they are equal, then we can use the corresponding angles converse to say that m is parallel to n. So 3x plus 5 must be equal to 65 degrees, which means that 3x must be equal to 60, which means that x is equal to 20, and this would make them parallel by the corresponding angles converse. I want you to go ahead and pause the video to determine if we have enough information on number 2 to determine if m and n are parallel. Then unpause the video and see how you did. Okay, the tricky thing about this problem is we have to remember that we don't know. We can't automatically say that this is 75 degrees because we don't know that the lines are parallel. So we have to use things that we know are true in general. So I know that this angle is 75 degrees because those angles are vertical. The parallelness of these two lines has nothing to do with that. I also know that this angle must be 105 degrees because these two angles and these two angles form a linear pair, a straight angle, and 75 plus 105 must give me 180 degrees, which now means now I can make a relationship between these two angles. Those two angles are equal, which means that these two lines must be parallel since these are corresponding angles. So yes, M is parallel to N by the corresponding angles converse. Okay, let's go ahead and apply these theorems with some proofs, and then we will wrap up this video. All right, we have been doing proofs for a few weeks now, so if you're feeling like pushing yourself, go ahead and pause the video and see if you can work through this proof on your own, or even pause the video and see what information you can fill into this table without my help, and then unpause the video and we'll work through this together. Okay, so as always, when I'm looking at this, I'm first looking for my roadmap. Here's what I'm given, that angles 4 and 5 are congruent. My ultimate goal is to prove that G and H are parallel. So if I'm trying to prove that these two are parallel, normally I could just conclude that with the alternate interior angles converse, but we're actually proving that the alternate interior angles converse is true in this case. So what we need to do is potentially find some relationship between angles 1 and 5 that would allow us to conclude, maybe using the corresponding angles converse, that these two lines must be parallel. So as always, we can start by just filling in our given information. We are given that angle 4 is congruent to angle 5. We know based on our roadmap that our ultimate goal is to prove that G is parallel to H. Line G is parallel to line H. I can identify, I notice this is telling me about vertical angles, and I can identify that angle 1 is congruent to angle 4. That is the vertical angles congruence theorem. And if angle 1 is congruent to angle 4, and angle 5 is congruent to angle 4, I can actually say that angle 1 is congruent to angle 5 by the transitive property. And if I know that angle 1 and angle 5 are congruent, which are corresponding angles, I can use the corresponding angles converse to conclude that G is parallel to H. And there we have it. Let's look at one more proof. On this proof, all of the statements have been given to you, and you're just trying to find the reason. So what I'm going to encourage you to do is to pause the video and see if you can do this on your own, and then unpause the video and see how you did. All right, hopefully you had time to work on this. We know these first two statements are given. So we are given that these two lines are parallel and that angle 3 and angle 1 are congruent. We know that angles 1 and 2 are congruent because the lines are parallel and those are corresponding angles. So this is just the corresponding angles theorem. It's not the converse because the angles are congruent because the lines are parallel. That is the corresponding angles theorem. The converse would say the lines are parallel because the angles are congruent. So corresponding angles theorem. Then we can say that angle 2 must be congruent to angle 3. Well, we said 1 is congruent to 3 and 1 is congruent to 2, so 3 is congruent to 2. That is the transitive property, going from 1 to 2 and 3, 1 and 3 to 2 and 3. That is the transitive property of congruence. So if I can say that angles 3 and 2 are congruent, then I can say that lines P and Q are parallel. These two lines must be parallel by what kind of angles are these? These are alternate interior angles. So this is going to be the alternate interior angles converse. And there we have it. Let's go ahead and wrap up this video. All right, in 4.5, we proved that lines were parallel, given information about the angle relationships when we have two lines that are cut by a transversal. We used corresponding, alternate interior, alternate exterior, and consecutive interior angles to look at these relationships to be able to prove and use parallel lines. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.